Okay, welcome back to another video on my channel, math_exe. Today we're going to look at divisibility rules. So this is a pretty important topic that is sometimes missed in some schools, I guess. And it's pretty important because it will help you solving like some division problems and stuff like that. Okay, so without any further ado, let's jump in to this. So we're going to check the divisibility rules from 1 to 10. So for 1, and this is pretty obvious because every single positive integer or every whole number is divisible by 1, and it's pretty easy to see is divisible by 1. There we go. Okay, so look, let's look at 2. So the divisibility rule for 2 says that a number is divisible by 2 if it is even, or in other words, its last digit or its ones digit is, let me just write it right here, is either 2, 4, 6, 8, or 0. So any of these 5 possibilities right here. So let's just look at an example of this. I'll just quickly erase this a bit. Okay, so let's say we're given a very big number, so we have 9999994. And this is pretty obvious, it is divisible by 2 because if you look at the ones digit, this is 4, and it's even because it satisfies this criteria right here. So therefore this number is divisible by 2. Okay, next we're going to look at 3. Now 3 is pretty interesting because a number is divisible by 3 if, let's say you're given a number, let's say 1881333. Now first thing, if you want to test the divisibility of 3, is you sum up all the digits right here. So what I mean by that is you turn this into 1 plus 8 plus 8 plus 1 plus 3 plus 3 plus 3. And you can just calculate what this is. 1 plus 8 is 9, and that will be 17, 18, and this whole thing will be 27. And you can check that, and you can check if this number is divisible by 3. If it is, then so is this whole number right here. If you are unsure, you can just do the same thing all over and over again. And then if you found the answer, then therefore we can just come back to the upper, like and you can just do it over and over again. So if you found an answer, if it is divisible by 3 or it is undivisible by 3, you can just jump into this number, the original number, and then you can just obviously tell if it's divisible by 3 or not. So the conclusion is you must first sum up all the digits right here. So sum up all the digits and see if this sum is divisible by 3. Okay, there we go. That's all what I have to say for this part right here. Okay, next we're going to look at the divisibility rule for 4. And let's say you're given a number like 9980. So first you're going to look at the last 2 digits right here, or I would say the tens and the ones digit, And you must see if this is divisible by 4 or not. If this is, then so is the original number right here. So this is divisible by 4. So we can just conclude that if you're dealing a number and if you're tested if the number is divisible by 4, you can just look at the last 2 digits. And see if it's divisible by 4. Okay, and next thing we're going to look at 5. 5 is a pretty easy one because you need to look at the ones digit or the last digit and see if it's either, and let's see if it's either 0 or 5. That is the two only options right here. So let's say we're just going to do an example for this. So we have, let's say we have 8, 8, 8, 8, 8, 8, 8, and so on. And then it ends up with a 5. And you can possibly tell this is divisible by 5 because the ones digit right here is 5, which satisfies this criteria. Okay, so 6 is an interesting one because if a number is divisible by 6, it must be divisible by 2 and it must be divisible by 3. So if you can conclude that, you must first see the ones digit if it's either 2, 4, 6, 8 or 0. And you must check also the sum of the digits and sum of the all digits is divisible by 3. And yeah, so let's just do an example of this. Okay, so let's see, what number should I? Okay, I'll just do 1, 8. Right here, and test if this is divisible by 6. So what you're going to do is test if it's divisible by 2, and you can already tell this is a yes because it's ones digit, it's 4. And if you want to test the divisibility of 3, you can just sum all the digits right here and quickly seeing this is equal to 18 and this is divisible by 3. There we go. So if we fulfill these two criteria, and then we can conclude this is divisible by 6. And then we can conclude this is divisible by 6. Okay, 7 is again an interesting one, but also maybe hard to understand. So given you have a number, let's say, let's do a pretty tricky one. Let's see. Let's see, 189. How about that? So we're going to test if this is divisible by 7. First, you're going to take the ones digit, and then you just keep that in mind first. And then you multiply it by 2. There we go. So you multiply by 2, this results in 18. And the next step is you erase this ones digit, and then you subtract this number by this number right here and see if this is divisible by 7. So in this case, our answer, just minus this, will become 0. And technically 0 is divisible by 7. So yeah, we can already tell that this is supposed to be a 9 originally. So this number is divisible by 7. Let's do another example if you're confused. Okay, so let's do 504. So first you're going to take the ones digit, keep that in mind, and then multiply by 2 to get 8. There we go. Wait. Okay, so you're going to subtract this by this. So you subtract this, and you get negative 42, which is divisible by 7. It doesn't matter if the result is negative, and because if you do it vice versa, you'll get positive 42, which is still divisible by 7, and it doesn't really matter. So we can conclude that 504, which is our original number in this case, is divisible by 4. So I'll just rewrite our conclusion right here first and test if this is divisible by 7. If you're not sure, you can just do the same thing over and over again. And if you reach a conclusion, you can just go back to the original number and say if that is divisible by 7 or not. Alright, so that's all I gotta say for divisibility rule by 7. 8 is a pretty tricky one to test out. So let's say we're given a large number, 999,800. So the only thing you need to do is to take the last 3 numbers. So in this case, we take the hundreds, the tens, and the ones digits. So, okay. And then after you take these 3 numbers, you're going to test if this is divisible by 8. And sometimes it could be very tricky to test out, and you might have to do some manual long division. But in this case, 800 is obviously divisible by 8. So we can conclude that this number is divisible by 8. Let's look at the number 9. Now the divisibility rule of 9 is similar to 3. So given a number, I'll just write 9999918, I guess. So it's pretty similar. All you need to do is to sum up all the digits right here. So after summing this up, you can quickly get that the result is 54. And you must check whether this is divisible by 9 or not. If you're not sure, you can just do the thing all over and over again. And if you're sure, you can just come back to the original number and you can just say this is divisible or not divisible by 9. So in this case, it is divisible by 9. So I'll just write the conclusion of what we got before. Okay, finally we have 10. And 10 is a pretty obvious one because you only need to look at the last digit and see if it's 0. That's it. So we're going to write ones is equal to 0. And probably I'll just do an example, I guess. So we're going to have a very big number, 8976218890. If this is divisible by 0, of course yes, because the ones digit is 0. So I think I'm going to do some example problems related with divisibility rules. So we're given the numbers 69a, and notice this is not a product of 69 multiplied by a. No, this is just a number. So notice I put a line above that. That indicates this is a whole number, not a product. And we're also given that a is between 1 and 9, including 1 and 9. This is because if it is out of bounds, and this will not be working anymore. So, and also we're given a must be a positive integer. So this number is divisible by 6, and you must remember your divisibility rule of 6. So we need to find a for this problem. So you may pause the video if you want to try this problem first. Okay, so hopefully you guys can solve it, and let's jump into the solution. So the first thing you might notice is, well, there are only limited choices of a. Why can't I just do trial and error? Well, that might not be very exciting. I'll just do the legit way to solve this. So remember, the divisibility rule of 6 is it is divisible by 2 and it's divisible by 3. So if it's divisible by 2, its one digits must be either 2, 4, 6, 8, or 0. And on the other hand, if it's divisible by 3, its sum of its digits must be divisible by 3. There we go. Okay, and let's see. So we know our ones digit is a, so we can just replace that. So a could be either of these 5 choices right here. So we already limited that. And the next clue, and perhaps this clue right here, is the sum of all the digits. Sum is divisible by 3. So I'm just going to write this right here. So 6 plus 9 plus a, and this must be equal to something that is divisible by 3. I'll just denote that as 3b, where b is a integer, specifically positive integer. So we can just simplify this thing out. 15 plus a, and it's equal to 3b. And we might be a little bit stuck right here because yeah, okay, so we're probably a bit stuck right here because b is a variable and a is also a variable, and it looks like we have limited clues to this. However, if we look at our question right here, we're also given our intervals of our intervals of a. This is between 1 and 9. So let's just use the maximum value of a, which is 9. So by substituting 9 right here and ensuring, since this is a maximum value, and therefore we must switch this into an inequality like so. So 15 plus 9 and this is greater than or equal to 3b, and this is equal to 24 after simplifying stuff, and it's equal to 3b. And we can finally get that b must be less than or equal to 8. And you can just do this by logic as well. So if you plug in a b value greater than 8, then a would be greater than 9, and that contradicts our like bounds of inequalities. So, and also from this question we are also given that a is at least 1. So let's just use that as our second advantage. So from, as we can do this like earlier, we can get that 15 plus our minimum value of a, which is 1. In this case our inequality flips to like so. So let's see, we're going to have 16 is less than or equal to 3b, and then we'll have b is greater than or equal to 16 over 3, which is 5/1/3. And given that b must be an integer, we can just rise up the bounds of integration, or I would say squeeze it. So we're just going to replace 5 we're just going to replace 5/1/3 by the next integer after 5/1/3, which is just 6. So we're given actually 3 possibilities of b, which are b, I'll just rewrite it here. So we can have 3 possibilities for b. We have b equals 6, b equals 7, and b equals 8. So let's just test things out, and let's just try to plugging in into this equation right here. So let's see, if we substitute b equals 6, we get 15 plus a equals 3 times 6, which is 18 on the right hand side. So just rewrite this for you guys right now. And from this we get our first a value, which is 3. And okay, so for the next one, we're going to substitute b is equal to 7, and in this case we have 15 plus a equals 3 times 7, which is 21. And then we can just quickly check that our a must be equal to 6. And then checking out 8, we can quickly get that our a. Okay, so you might think that these are the answers, but however, from the first criteria, where it's divisible by 2, a must be either of these choices right here. So after a moment, we can eliminate a equals 3 and a equals 9 because it doesn't apply to our first rule, where a equals 2, 4, 6, 8, or 0. Therefore our only answer is a equals 6, and that's the only answer for our problem right there. And yeah, hopefully you guys enjoy this video, and please subscribe for more, because I'll be planning to upload more videos in the future. Now see you guys in the next video. Goodbye.